Welcome to the session on the normal distribution, the inverse normal distribution function. The objectives for this session are to find for a given probability P the value A such that probability of x less than A equals P. So let's see how we can find for a given probability P the value A such that probability of x less than A equals P. Some calculators call this function the inverse normal distribution function. Let's begin by looking at an example. You may be familiar with this already, so you can pause the video and have a go. Press play when you're ready to view the solutions. Let's consider part A first. Given that x is distributed normally with mean 15 and variance 4 squared, find the value of A, correct to 3 decimal places, such that probability of x less than A equals 0.65. So let's solve this. The region on your screen represents probability of x less than A equals 0.65. Your calculator will require you to input the mean, the standard deviation, and the probability. The mean is equal to mu equals 15. Notice that it appears in the center of the diagram. The standard deviation is equal to sigma is equal to 4. And the probability P is equal to 0.65. When inputting these values into your calculator, you should obtain that A is equal to 16.541. We can also check the reverse. Try checking to see if probability of x less than 16.541 equals 0.65. Now let's take a look at part B. We are required to find the value of A such that probability of x greater than A equals 0.3. So let's solve this. Notice that probability x greater than A equals 0.3 implies that probability x less than A equals 0.7 because the area under the entire curve is equal to 1. And of course you can see that 0.3 plus 0.7 is equal to 1. So this region here represents probability of x less than A equals 0.7. Now we can get our calculator out and input the mean, the probability and the standard deviation to find this value of A. So our mean is equal to 15, standard deviation equals 4, and probability P is equal to 0.7. So inputting these values gives us that A is equal to 17.098. And again, we can check the reverse and verify that the probability that x is less than 17.098 equals 0.7. Now let's take a look at part C. We're required to find the value of A such that probability that x is between 10 and A equals 0.4. So let's take a look at this in pictures. The probability that x is between C and D is this diagram. This is equal to the probability that x is less than D minus the probability that x is less than C. Let's now connect these diagrams to our example. So we have the probability that x is greater than 10 and less than A equals the probability that x is less than a minus the probability that x is less than 10. And so we have 0.4 equals the probability that x is less than a minus the probability that x is less than 10, which equals 0.10565. We can obtain this by inputting the mean, the standard deviation, and the upper and lower limits of the interval. This is from our previous session, and we can do this, of course, on our calculator. Rearranging this gives us that the probability that x is less than a equals 0.50565. And for x distributed normally with mean 15 and variance 4 squared, we have that a equals 15.05665. And again, our calculator will require us to input the mean, the standard deviation, and the probability in order to obtain this. We can again, as before, check the reverse. The probability that x is less than 15.05665 is indeed equal to 0.50565. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. The masses in x grams of a large population of ducks are modelled as a normal distribution with x distributed normally with mean 450 and variance 30 squared. Given that 70% of ducks have mass less than x grams, find x. So let's solve this. The probability that x is less than a particular value of little x equals 0.7. This comes from the fact that 70% of the ducks have mass less than x grams. Again, we'll need to input the mean, the standard deviation, and the probability to find the value of x. So our mean is 450, our standard deviation is 30, and our probability equals 0.7. And from this, we can input all these values and obtain x equals 465.732. Now let's take a look at part B. We are required to find the interquartile range of the masses of the ducks. So let's solve this. We have that x is distributed normally with mean 450 and variance 30 squared. And also we have that the probability that x is less than q1, the first quartile, equals 0.25. That's a quarter of the way along. And inputting the value of the mean, the standard deviation, and the probability will give us the value of q1. So the mean is 450, the standard deviation is 30, the probability is 0.25, and therefore q1 equals 429.7653. We also have from the definition of q3, the upper quartile, that the probability that x is less than q3 equals 0.75. So again, in our calculator, we can input the mean, the standard deviation, and the probability in order to find the value of q3. So in our example, the mean is 450, the standard deviation is 30, and the probability is 0.75. And therefore, inputting all these into our calculator gives us that Q3 equals 470.2347. Now that we have the values of Q1 and Q3, we can find the interquartile range. and the interquartile range equals Q3 minus Q1, which equals 40.47. This brings us to the end of this session. If you have understood its contents, you should be able to find for a given probability P the value A such that probability that X is less than A equals P. Thank you very much for listening. To understand this session in greater depth, do attempt the exercises in your textbook related to this topic.